Okay, good evening. Let us start today's lecture. As mentioned, today we are still looking at OP, right? In fact, we'll look at OP this week. I mean, we did look at it last week, this week, and next week. Right. After next week, it will be one more week of revision lecture. Okay, so this is actually a well-being day, right? Well-being day. Okay, so well-being day, really not supposed to have class, but there's really no place to reassign this. Anyway, it's just a revision lecture, right? So it's nothing about nothing topical. So it's a revision. If you want to attend, you can attend, right? If not, you can wait for the video to be posted. So what we will be going through in the revision will probably be on the PE2 and the final exam. Same as the revision we had, right? We will go through last year's P2 and last year's final exam. Okay, so we are here in week 11. We talk about inheritance. Okay, so we'll be talking about OP for these 3 weeks. So today's lecture may not be that long, right? Because we talk about inheritance is one topic. But we found that if we put too many new concepts in one lecture, it's a bit hard to follow. So the lecture duration may not be long, but at the end of it, we can always have today I don't have to go off early. Okay, so we can have a time of consultation. Okay, after today's lecture. All right, so PE2 will be here. Okay, it will be after Good Friday. Okay, so Good Friday is 15, so 16. Timing will be the same. Sitting plan timing same as your PE1. Okay, hopefully we'll fix all the technical issues. So I think next week, should be next week. I'll be going down to the lab to go and see whether we have fixed all the issues or not. Okay, so there are some labs with some problems, right, with the compiler and all that. So we'll go down and try to do one more run through, okay, to check all the installation. Okay, for those who missed the PE2, okay, they will make up PE. So remember, we said we will do a progressive grading. So if you miss PE1, you can take PE2 as your final. But if you miss PE2, then have to do makeup, right? So the makeup, if you miss PE2, we will arrange it on the afternoon after final exam. This is mainly for your convenience, so you don't have to take extra day of leave, right? So final exam, I think, is 1 to 3 p.m. Like this time round is afternoon exam. So after the exam, we'll quickly come back to Com 1. Okay, then we'll have our PE in the afternoon. Okay, so you don't have to take another day of leave and come down to campus another time, right? Okay. No, this is if you miss PE2. Okay. So last week we talked about encapsulation, which is the idea of grouping data and function together. And so some short revision. So in the old days, a procedural model means your data and functions are separate. Okay, so what you do is you have functions, okay, that operate on the data, and you pass the data into your function. Under the OOP model, you have what we call encapsulation, where data is encapsulated in a function. So you see data is captured inside, okay, the object. Okay, so not typically we make our data private, so people do not access our data and instead we give them functions, okay, to access our data here. So we can control exactly how our data is being modified, right? So what we did was we created a bank account class, right? So in OP, they have very similar properties or rather methods, okay, just like an abstract data type. Okay, so a class is like a data type. Instead of having the data and the function separate, they're now combined into one. So the constructors for a bank account class could be a bank account. Okay, so there are two constructors here, one with account number, one with the initial double amount. Okay, so if you don't have an initial amount, we default to 0. Okay, so we can customize, okay, multiple constructors, okay, by having different inputs. Okay, they all perform different default actions, right? We have accessors, so we have accessors to get account number or get balance. We have mutators, things to help us mutate or change the state of our data. So deposit and withdraw. So notice that to change the state, we have to go through deposit and withdraw. So you cannot directly go and change the bank account balance to whatever you want. Similarly, you notice that there is no mutators for your account number. So once the account number is created, it cannot be changed now. You can access the account number by retrieving what the account number is, but now you cannot change it. Right? It makes no sense. I mean, you should not be allowed to change your bank account number once it's created. Right? At the end of the day, if you want to close your account or delete the account, right, there's a destructor here. So a destructor is the same name as the class, same as your constructor, with an extra tilde in the front. And destructor have no inputs. Okay, this is the fixed signature of destructor. Because destructor have no inputs, there can be only one destructor. Okay. So destructor was something new we talked about last week. So why did we need destructor? It's because we are now allocating memory from heap. In the past, we used to allocate memory on stack. Every time we call a function, we declare new variables in the function itself. Right? Those variables or structs or whatever are created on the stack. Right? So just like you call foo, there's a object being created on the stack. So when the function quits, the memory that's being used on the stack will be freed up, right? It will be able to be allocated to other functions in future. Okay. But when we use ADT, it turns out sometimes your ADT needs to instantiate objects. It needs to create extra objects that is not found on the stack. And this creation of new objects will be done in the heap memory. Okay. What they call heap, you will learn about it in 201 or in your operating system class, right? Where heap is actually a special data structure. Stack, we all learn is a data structure, right? Where you stack. Okay, we learn this. Heap, you will learn it in 201. It's a special data structure. So in a sense, the memory is organized in a heap. That's why they call it a heap memory. Okay. But how it's organized, okay, we don't have to know the details yet. Not for our class. So if you look here at this little piece of code here, when you call function foo, all right, you call function foo, inside foo, you create a queue. So this queue is on the stack, right? This variable queue, or rather this is a struct lah. I mean that represents our queue. Okay, it's on the stack. When you enqueue and enqueue again, we are creating new link nodes, right? In memory. And such that when you dequeue, of course, you will remove them. Right. Now, this one is procedural way. Right? Notice because the queue is a struct, and then you're putting a queue into the function here. Okay. But it's similar if you were to write a queue in using OOP. Okay. When you create a new node, you create on the heap. Now, when you are done with the function here, so function foo is done. This foo here is reclaimed, right? So all these arrows are gone, but the heap, you have still created it. Okay. I mean, this heap memory is still being used. Okay, it's not freed up. So you have a memory leak here. Okay. So how to solve this? Well, you need to delete let me see how to go back. Okay, you need to explicitly delete all these items, right? Once this foo is going out of scope. Okay, so that's the purpose of the destructor. Okay. Okay. Now let's talk about this ways to instantiate classes. So if you look at foo, okay, what is the difference between the following way? Okay, so let me go next. Okay. Wait, my arrow is a bit off. Okay, one arrow. Okay. So let's say you are in function foo, right? Or function main, whichever function you have. And we want to create bank instantiate bank account. Right? Instantiation is a new term we learned last week, right? Instantiation means creating an actual object out of the class. So the class is like a blueprint. Okay, it defines a template. Okay, I make sure you use the word template because C has template. It's a blueprint. Okay, when you instantiate, you are creating an actual object, right? It's like a variable. Okay, so in memory. So there are a few ways to do that. Let's look at that one by one. The first way is to create a pointer to a bank account. Okay, so pointer here, pointer to a bank account. Okay, it's called BA1. Now, when you create a pointer BA1, what gets allocated in your memory? A pointer gets allocated. So this pointer is enough space to occupy one address. An address, if it's 64-bit computer, then it's 64 bits. 8 bytes of space. It's an address. Here we did not initialize. So this brown yogurt signifies random values inside there. Okay, so it points to some wrong segment in memory. So if you try to access it, you might end up using some getting some yogurt. Okay, so what you should do is good practice to put now. Okay, you put now, then it will set to 0, and now it's equivalent to 0. So here this will be now. So if you accidentally try to dereference and access, you cannot. Okay, because it's 0 is not a valid memory address for you to access. Okay. Okay. The other way is, say, if you call new bank account every time you use new, this allocates in heap memory. All right. So this line is actually a two-step instruction in sense, right? So the right hand side will evaluate first. Okay. This will create a bank account in heap memory. Okay. So this one uses the single input constructor. So account number is 2222 with no value inside. All right. Then once created, BA2 is a new pointer. Okay. Pointer to a bank account, and you assign it to this. So this new always returns the address, okay, of the newly created object, okay, instance. So we assign it to BA2. So BA2 will contain the address to here. Okay. Inside here is the address. So I point it this way. All right. So this is allocated on the heap. The next method of doing this one, basically you call BA3, okay, but there's no new here. Like there's no new, so it allocates on the stack. So you create here, you will set aside enough space, okay, to store the bank account. Here's in, here's double, so probably 4 bytes plus 8 bytes. So, I mean, depending on how many bytes the in and double takes. Okay, and that's probably it. Okay, so you create the space here, set to 3333. So this is the BA3. Okay, so the question is now, which method should you use? It depends on what you want to do, right? There's no saying that this method must be the only method, right? So all three methods, right? 1, 2, 3, okay, are methods you can use depending on what you want to do. Okay, they are all valid, okay, ways of instantiating a class. Okay, so obviously, if you have BA1, next thing you can do, you can assign BA1 to the address of BA3. Right. So BA1 is a pointer. BA3 is not a pointer. BA3 is the actual instance itself. So you get the address for BA3, you assign BA1 to point there. Okay. You can also set BA1 equal BA2. That is fine. Do you need any star or not? Let's check it out. So BA2 is a pointer. So it contains address. BA1 is also pointer, so it should contain address. So you can assign directly like this. So if you do this, then the BA1 will point to here. Okay. So to check whether you need star or not, you must make sure what is your type. And what is the type of the variable. Okay. Now, before this full quits, there's something you must do. You must explicitly delete away this BA2 if you intend to delete away, right? You do not need to delete away BA3 because BA3 is on stack memory. When it's done, okay, the BA3 destructor will be automatically called, okay, because it is going out of scope, right? Last week we did this simple experiment, right? I mean, we ran some code to see being born and being destroyed, right? So the moment we know when the scope of full ends, so this is the scope, right? When the scope of full ends, all variables will be destroyed. Okay, so their destructor will be caught. So these are pointers. So some pointer destructor will be caught, right? Not our bank account destructor. So this will be destroyed. This will be destroyed. Okay, BA3 will be destroyed. The BA3 destructor will be caught. Okay, basically BA3 bank account destructor will be caught. However, whatever was on heap memory will still remain there. So in order to prevent dangling things, you must call your delete BA2. Okay, so explicitly delete this. Okay, later. All right. Now, this is beyond the scope of the class, right? You don't need to delete BA1, right? Because BA1 is a pointer. Okay, so Zhen Chong asks, okay, if you assign BA1 equal BA2, you're just doing this, right? So here you delete either BA1 or BA2 is fine because you are deleting this thing. Both point to it, right? So anyone you delete is good enough. Okay, so anyone you delete, okay, it will delete this. All right, so whichever one is good enough. Okay, the whole point is you want to delete this. Okay, you don't want to just delete this. Okay, so everything here will automatically delete for you. It's only the heap memory that will not delete. All right. Now, something beyond the scope of this class, right? So some of you will be doing software engineering or writing other code using C++. So you might realize, oh, this is quite troublesome, right? Why don't we have certain ways of, once you delete a pointer, it automatically go and destroy this. Okay, so yes, there are special pointer ADTs that C++ have in the standard library, right? Called smart pointers. Okay, it's beyond the scope of the class, but you can use smart pointer. There are certain pointers called unique pointer. Okay, in the past, there's this called auto pointer, but the auto pointer had some problems, so it was removed since C14++. And so C++11 has auto pointer, but auto pointer was buggy. So the definition was not well thought out, so it was buggy. So they decided, so the ISO decided to remove it from C++14. So there's things called unique pointer and all that. So those are not normal pointer object here. They are special ADT pointers. Okay, they're not your regular run-of-mill star pointer. They are actually special ADT pointers, just like how vectors are your special arrays. Right? We have used vectors because there are more functionalities behind them. Okay, although the vector underlying also use array somewhat, but the management is done by vector. So they do have certain special pointers, smart pointers and all that, right, to do management. So those pointers, okay, they have a destructor that go and destroy the heap memory. They have that. Okay, so but of course you can also mess that up. Like for example, you have BA1, you have someone else pointing to here. Then you go and destroy this and automatically destroy that. And oh no, right? Your other parts, okay, gets destroyed. So of course there are other inherent problems with that. Okay, so if you want to use those, you have to be very clear of what you are doing. Okay. So, but that's outside the scope of this class. Just let you know, C++ have more advanced tools. Okay, so basically there are two ways: allocate on stack or allocate on heap. Now, when to use what, right? So, if you do not need the object to persist outside of the current scope, then no worries, allocate on stack. Like sometimes you need a temporary variable to transfer things over and all that, right? To do calculations or do whatever in your algorithm does. As long as it's temporary and within the scope, then you can just do it on the stack, no problem. But if you want to persist beyond current scope, for example, if you are adding a new link node to your linked list, right? Obviously you want the node to persist beyond the method that adds the node, right? You don't want it just to be destroyed. That's why we create the new node on the heap. Okay? And when you do that, you must be mindful of ownership. Okay, normally the rule of thumb is whoever creates the node, whoever creates the object on heap it is their responsibility to go and deallocate, to remove it, delete from the heap. Okay, generally, you follow that, you are generally safe, right? So if you create on heap, must always make sure you delete. Okay, so that's what we call mindful ownership. So this one I mentioned before, C++ and beyond has smart pointers to take care of all this deallocation. Okay, you can go and read up about it if you want to use it. Okay, so that's the brief review of last week's topic. Okay, today we will go into a new one called inheritance. Okay, so like father, like son. Okay, so really inheritance means what the English word inheritance means. You take something from your parents. Okay. Okay, so let's take a look at the motivation, right? Why do you want inheritance? Okay, so let's say, for example, we already have a bank account class to capture bank account. So obviously, my bank don't just want to have bank account. We came out with this idea, oh, let's have a savings account. All right, a savings account is a bank account that generates interest. Okay, so it means you want people to use your bank, right? You create this savings account, so it generates interest. A normal bank account that we had last week don't generate interest, right? So our savings account, okay, so let's define this class. So the data will be the same, right, as a bank account. It has account number, balance, and one additional data called interest, right? The interest rate. Okay, operations same, deposit, withdraw, of course, get account number, get balance, but one new operation called credit interest. So the idea is probably once a month, right? Maybe every day. At the end of every day, you call credit interest to generate interest. Okay, or you do it at the end of the month. Okay, you do some kind of a average balance in the month, whichever way, but you call this credit interest. Okay. So let's take a look at how we define this savings account class. Okay, so class savings account, private, okay, account number, balance, interest. Okay, so we all set to zeros and zero. Okay, account number, well, you can't set default account number, right? It makes no sense. Okay, so we leave it blank for now. Okay, then constructors, okay, constructors, here we have withdraw is the same, deposit is the same. Okay, credit interest. So here, credit interest is very simple. We just look at current balance. Okay, we don't want to look at balance of history, whichever. Keep things simple. Current balance, okay, you multiply by 1 plus interest. So if interest is 0.5, 0.5 is 5%. Well, that's a very high interest, right? If our interest is 0.5%, so it'll be 0.005, right? In a sense, so 1 plus this, so you multiply your balance with this. Okay, so we have this one new property, one new method. Okay, so this is what is new in our savings account. Notice that if I overlay this in bank account, it's bank account, right? This is the only new thing that savings account has over bank account. Okay, so the thing you note is that savings account shares almost more than 50%. In fact, I would think 90% of the code is the same. Only this few lines is different, right? So just as how in function abstraction, if you have two functions that does mostly the same thing, you can probably find a way to write a function, okay, a more general function, and then call other function. Okay, so we should avoid cutting and pasting code. Right? Why should you avoid cutting and pasting code? Because it's very difficult to maintain, right? If you find some bug says you copy and paste, maybe you find your withdraw have some problem here. Okay, you made an error. Then you must go and remember which are all the parts that you copy and paste code and go and fix the bug. Or if you want to extend something, you want to create a new a modification or an extension, then you must remember, oh, where do you copy and paste this code, right, to go and modify. So it is not very good to cut and paste code. And so in software engineering, they have this term, right, called DRY, right? It's called don't repeat yourself. Okay, so when you go to do your software engineering class, okay, you'll be taught it's very bad practice to duplicate codes. Okay, because normally when you duplicate codes, you want them to work the same way. So if they want them to work the same way, what you do is you create a more general function. Okay, so you should not cut and paste code. Okay, so this is the DIY principle. Okay, now another problem with cut and paste code is that now classes are independent. Okay, functions that work on one class cannot work on another class anymore. So for example, if you have a procedural procedure that transfers money from a bank account to another bank account, right? Now this transfer will not work on saving account objects. Cannot, right? Because it works on bank account. So you must go and write a transfer for savings account. Okay. Then end of the day, the logic actually is the same. So again, more copy and paste code, right? So you have this problem as well. Right? Another problem I don't think I put here is interoperability, right? So does it make sense to transfer money from a bank account to savings account? Yeah, it makes sense, right? The only difference is that savings account got interest, right? End of the day, money from bank account to savings account should be the same, right? So even if you have a transfer function, right, then you must write one transfer function for every single class. That is for one for savings account, one for bank account. Then you realize things become your amount of code explodes quite quickly, right? You can easily imagine, right? So you have a transfer from bank account to bank account, savings account to savings account. You have bank account to savings account and savings account. You already have this combination, right? If you have 3 different types of bank accounts, then you have even more combination. So this is what they call a state space explosion, right? Basically, it's this is a combination of 2, right? Okay, right. So this is where the idea of inheritance come in. Inheritance basically is a OO paradigm. What you do is you allow classes to be derived from another class. In a way, you inherit. Okay, so a new class will inherit all the attributes and all the methods of another class. Okay, so we draw it like this. Okay, so if I draw this way, class B derives from class A. So it inherits. Okay, inherits. So B is now known as the subclass of A. Sub meaning down, right? Sub is down, like subscript. Okay, A is the super class of B. Super meaning up, right? Super doesn't mean more powerful. Okay, super means up, like superscript. Okay, so sub is down, super is up. Okay, so this is the terminology. Okay, so how to define a subclass? Okay, so the syntax is this: class B colon public A. Okay, so this indicates, so colon A obviously means that B will be a subclass of A. All right, so B will be subclass of A. Now, why public? Public means you are telling the world, okay, this relationship is made known to the world, right, to everyone, that you are subclass of A. It's possible for you to use the other accessibility modifier, which we learned last week, right? There's for C++, there's private, there's protected. Yes, you can do that too. Okay, but what happens is beyond the scope of this class. Okay, we will not go too deep into that. Basically, in a sense, you are keeping your inheritance private. Okay, if you use private, that means nobody but yourself know that you have this inheritance. Everyone else say, look at A and B as 2 separate independent class, but within B, you have privately inherited. Sounds like some illegitimate child there, right? You don't want the whole world to know, right? The kind of thing. So that's private. Protected is in between. Only those in your family, your family tree knows about your inheritance, kind of thing. Okay, so private, only you yourself know. Protected means you and your descendants know about your relationship. Okay, but again, protected and private are slightly more complex mechanism. We will not talk about in in this module. Again, this is C++. Most programming language only allow public inheritance. For example, Java, Swift, okay, they only allow public inheritance because private and protected is a bit rare and uncommon. Like why you want to keep your relationship private. Very few examples of requiring this. That's why most programming language do not even support it. Like for Java, your inheritance is made public. Okay, so C++ is being more specialized and allow you more final grade control. Okay, which may not be that important or that widely used. Now, let's rewrite our savings account using inheritance. So our saving accounts class, my class savings account is publicly inherited from bank account. So we are subclass of bank account. Under our private properties, we only need to add in the properties, okay, that bank accounts do not have. So bank account used to have the account number and the balance, right? So these two properties we will inherit. Okay? So we only introduce our own property called interest. All right. So how about, okay, so we do this. Okay. Okay. So what exactly are we inheriting? Are we inheriting? We are inheriting all the public and protected properties. Okay. So all the attribute and properties will be inherited. Not all. Public and protected. So if you make your properties private, I think we have a problem here. Private, then the properties cannot be inherited. Okay, we'll see later. So only public and protected. So protected is like your family. Private is really personal. Okay, public, of course, to everybody. Okay, so properties and methods, right? So with an exception, okay, constructors are not inherited. You cannot inherit a constructor. Okay, so your subclass have to create a constructor. You have to define your constructor. Now, when you define a constructor, sometimes you will need to initialize, okay, the properties, okay, that your superclass have. Like savings account, the constructor for savings account will take in account number, balance, and interest rate. Okay, for example. Now, interest rate, we will set ourselves. Right? This is our property, right? It's a new property that we have. Account number and balance is your superclass property, your parents. Okay, let's use the term parent as well. Your parents' properties. Okay, so they should be responsible on how to manage the these properties, right? So they should be the one doing the initialization. So how do I call, okay, my superclass constructor? It is done by using initialization list like this. So you put colon, you say bank account. So this part here is basically the constructor of your superclass. So this one will activate and call before you run, okay, your function. Okay. So this is the way we do the constructor. Okay, so let's see. Yeah. So here we had a double interest. So now here we have our savings account. Okay, so this is our account number, balance, and interest. And then we put, so notice we haven't started the function yet. The method starts here. Okay. Here we put colon, bank account number, and this. So this will call the superclass constructor. Then here we add our own interest. Interest equal interest. Now because I put an underscore here, I don't need to put self arrow interest. I think they are different. Right? So this interest has no underscore. This has underscore. So maybe that's why people put underscore. Easier. Okay, these days, the style seems to go out of fashion. People don't put underscore anymore. So these days, people just call a self arrow interest. Okay. Here we have our own method. Okay, credit interest, which basically credits the balance. Okay, so publicly, these are all the nodes again, called superclass. Okay, okay. Now, when you compile this code, you have a problem. The code says error. Why? Bank account balance is private. Here, you attempt to access balance, right? Here, you attempt to directly credit balance. Okay? Your bank account has declared balance private. Means nobody except bank account itself can modify or touch balance. Okay. So here, we may get away with using get balance, right? Correct, bank account, get balance. But here, how to do this? Maybe use deposit. Maybe you can use deposit. Get balance multiplied by interest. You can do this. Okay, so deposit is a public method. Okay, so we can access. Get balance is a private method we can access. Okay, so we can use deposit to do this. Okay, but why should we not use deposit? Okay, so we must think very carefully. Should we use deposit or not? Again, it depends on what we want the behavior to be like. If we think a little bit further, maybe deposit may introduce some kind of tax, right, or charges. But every time you deposit, we will charge you amount of money. I don't know, for example, right? Should you really, in crediting interest, go through the depositing method? Because crediting interest is actually not like deposit, right? If you think about it, no one actually, you are not, deposit is maybe someone else come and put money in your account. Here, we're not actually depositing money in the account, right? This interest is deposited by the bank, but it should not incur any kind of property, tax, charges or fees, whatever they come with normal deposit. So maybe it's not a good idea to use the deposit here. Okay, maybe. So we might not want to do this. Maybe it's better to directly go and update the balance. All right. So Jerome asked the underscore interest equal interest part. Okay. Here I did put virtual lah. Okay, so if you put virtual, this virtual only comes into play next week when we talk about polymorphism. So that's why sometimes here I forget to put virtual lah, because sometimes we also forget to type the word virtual in. But here you put virtual or no virtual, for now there's actually no difference. Right? Okay, the virtual only comes in when we talk next week. Okay, when we talk about polymorphism, then the virtual becomes important. All right. So Jerome asked, our constructor has a public, wanting interest to be private. I actually don't get the question. When you create a savings account, you need to initialize with an interest, right? Because our interest is private, yes. And after this, there's no way to change the interest. Okay, it's private, so no one can change the interest anymore. I mean, of course, if you want, you can go and create a method that says modify interest or not. Right. So here, our interest, once initialized, interest is fixed. So our savings account, once you create, the interest is fixed. Okay. So this one is basically initializing, assigning some value here. So we do it through the constructor. So the constructor is the initializer lah. Some people use the term constructor as initializer, which is almost the same thing, right? Technically, you don't construct the object in the sense the object is already constructed. You are initializing the values of the object. That's why some in some languages, the terminology are called initializers. Okay. If you want interest to be public, you can still always initialize here, right? No difference. I mean, nothing wrong with initializing it. Okay, so you can use this constructor as an initializer just to initialize the value. Okay, even if this is public, right? No, this underscore is just a naming convention. Okay, so if you want this, if you don't put underscore here, you cannot do interest equal interest, because this interest refers to this one. This is the scope, right? So what does it mean by interest equal interest? You're assigning this to itself. Okay, so to get to this interest, you need to use this, right? Is it this? This arrow interest. Okay, so interest on its own refers to the nearest scope. This refers to the instance. Okay, so this arrow interest, arrow because this is a pointer. Okay, so because it's a pointer, you use arrow to access the property of a pointer. All right. So here we don't use this because I named it differently. Like I put underscore here, so the name is different. Okay. So balance is private. Okay. So a quick recap of accessibility. Okay. So now you know that now there's a difference between private and protected. Okay. So public, everyone can access. Okay. Private, only the same class can access. Now protected, same class or subclass. So protected now extends to subclass. Right? Last week we didn't know learn about inheritance. So protected doesn't mean anything to us. Okay, so today we learn inheritance. So we learn protected is meant for this inheritance. When you want your family or your descendants, okay, yeah, the term we use is really like a family tree kind of thing, like parent, child, descendant. If you want your descendants, okay, to have access to the methods or property, then you use protected. So to outside, okay, it's still private, they cannot access. Right? So bank balance, maybe you think, okay, I trust my descendants enough. Okay, give them direct access to the bank balance. After all, they are also bank accounts, right? So they should be able to access and deal with the balance accordingly. All right. So I may change to protected. So here's an example. Okay, so class A has a private A, protected B, and public C. Okay, so class B is subclass of A. Okay, so let's go through one by one. Can I see out A? Cannot, right? Because A is private. Cannot. A is private. Can I see out B? Yes, can see out B. Okay, so yes, can see out B because B is protected. But that means B can see. C, of course, C public, everybody can see. Okay. Now, how about if I have a main class like this? So here I have main. Okay. So main, I say B. Now, can I do B dot A? B dot A obviously cannot, right? Because B himself already cannot see A. Okay, so B dot A is error. Okay, error. Can I do B dot B? B dot B. B is here. Okay. B dot B cannot do. Okay, because B dot B is protected. So only the descendants of B can see B. Okay. B dot C is public, so of course can see public. Okay. Right. Okay, next. Okay. So in a way, public anyone can access. So you have this thing that I drew, right? So public, everyone can access. Protected, only the subclass can access. Private, only yourself can access. Okay. So suppose we want savings account to access balance. Okay. So we change from private to protected. So we say, okay, savings account, we actually account number, maybe account number I may put private. I mean, maybe I will just put account number to private in a sense, because then nobody can change. In this case, savings account can technically still change account number. Okay, so maybe I want to keep account number to private. Okay, perhaps because after all, it's supposed to be read only. You have a method called get account number to get it, right? So your descendants can still use that method. Okay, so we make the private properties now protected. Okay, so alternatively, you can create okay, this is what I mentioned just now, right? Alternatively, you could use deposit and get balance. Okay, so you call the superclass mutator and accessor. Okay, so which way should we use? So again, just now I mentioned, if you call deposit, there may be some unintended side effects of a deposit. Okay, because deposit we may intend for people to actually use it to deposit money. So as crediting interest, it may not be exactly the same effect as depositing money. So we may not want to do it this way. Again, depends a lot on your design, how you are designing your class and your functionality. Okay. Right. So one observation we see is that using inheritance, we now reduce the amount of redundant code. Okay, we do not need to redefine account number, balance, withdraw, deposit, right? So whatever that bank account had, we can reuse it, right? So it saves us time for writing new code. Again, it saves us time in terms of maintainability, right? If there's a bug we need to fix, okay, there's only one code that we need to fix. Everyone uses the same piece of code. If there's any modifications that we need to do to enhance functionality or what, there's only one code that do it. Okay, so that is a good thing about inheritance. Access to property, we can give directly using protected or through mutated and accessors. So maybe I might want bank account account number to remain private, right? And notice this whole thing improves maintainability because the code in bank account remains untouched, except for changing the private to protected lah. Because we need to release the thing, right? Or rather, in the first place, when you write bank account, you already imagine inheritance taking place and you properly put protected. Okay, so not everything you want to just put private. Okay, because we want to allow our code to be open to extension. All right, so in a sense, our bank account remains untouched. Right? So since bank account remains untouched, other programs using it are not affected. After all, private become protected, other programs cannot see also, right? So to them, there is actually no difference, right? So if you need to modify withdraw in bank account, saving account do not need to change. Okay, so this is the maintainability. Okay. Okay, let's take a look at usage. Okay, usage. Okay, so let's see here. We create a bank account called BA, bank account bar. Okay, 1, 2, 3, 4, $500 inside. Okay, we have a savings account called A88. Start with $1,000. Wow, 2.5% interest. Wow, nice interest rate. Okay, so SA.print. Assume that we have a print function. I know earlier we did not define print method. Okay, so assume we have a print method here. Okay, then display a submit account. Now our savings account can do everything here that a bank account can do. Okay, so when I draw our diagram like this, I said savings account is a bank account. This is what we call with inheritance. It is a relationship. So savings account is a bank account. That is a relationship. Okay. So any property or method that bank account class have, of course, public and protected ones. Okay, I can access along with my own ones, right? Credit interest. So here I put my own properties and methods, and here I put the bank account properties and methods. So I basically draw this line lah. So here are the properties, and here are the methods. Okay, methods. So Now, sometimes we want to modify the inherited method. For example, in savings account, right? Our print should also print our interest rate. I mean, should not just print the bank account number and savings balance, right? Should print the interest rate as well. Okay, so what we do is basically this thing called method overriding. Override. Okay. Override. Override means I want to do something, your superior come, I override you. Okay, I override you. It's like veto like that, I override. Okay. So, but in this case, it is the descendant that overrides the parent. Okay. So you define a method with the same signature and a subclass. Okay. So your method header equals to this, right? So signature, this is your print. Okay. So basically, it must be the same method, the same name, and same parameters, same inputs. Okay, then you are considered override. Okay. Override is not the same as overload. Override is not overload. What is overload? I wonder whether I got a slide here. Suddenly I can't remember whether I have it. I think I don't have that. Okay. Override is not overload. Okay. What is the difference? When did we talk about overloading method? When we talk about constructor, right? Yeah. Okay, so Melvin is correct, right? Overload means same name, different inputs, right? Different inputs. That is called overloading. Okay. Overriding is same name, same inputs, but in a subclass. Okay, so this will override. Basically, I must be identical. Then I override my parent class. Okay, method. Okay, so this is two very similar terms, very similar behavior, but actually functionally different. Okay, overload is same name, different inputs. Override is exactly same identical. Okay, so let's take a look at this example. So method overriding. So bank account, suppose I have a print here. Okay, so here I print my account number and then balance. Right? So when I call this print, we will print account number and balance. Okay, so my savings account, I will overwrite the print. So same name, same input. This is empty input. I print has empty input. Of course, return value must be the same. Okay. So I'll print account number, print balance, print interest. Now, if you look at this, already this big warning come, right? We have duplicate code. Right? This and this are duplicate code. So you should be very shocked to have duplicate code and remember this. No. Okay, we should not have duplicate code. So is there a way for us to reuse bank account print? Notice the bank account print does the same thing here, right? Can we in our savings account print call bank account, go and print first, then I print the interest? Yes, of course, there is a way to do that. Okay, basically, you will write this thing here. Bank account print. Here you use double this colon notation. Okay, so it's not just a dot because it is not accessing a concrete instance. Okay, it is accessing a class method. So you put this colon. Okay, so when you have this will call the superclass method, bank accounts print method. Okay, so bank account print method will print account number, print balance. Okay, then after that, then you print your own interest rate. Okay, so this is how you reuse a superclass method, or call the superclass method. And it doesn't have to be print. It can be any method you want to call for in the superclass. Okay, you use this thing. Okay. Now what happens if you just call print? Say you do have this. You just call print. What do you think will happen? Which print will this refer to? Yeah, so this print will call this print, right? We should call this print again, and so you have an infinite loop. Okay, so you will have infinite loop. This print will call this print, and inside this print you have this print and call this print. You end up calling itself. Okay, so it's infinite loop. It won't even print the interest. Okay, so Jerome asks, if you don't use bank account print, would saving account print the account number and balance? So if you don't use the bank account print, then you must duplicate the code here. You must go and write code like this. You must write this code down. But we have mentioned earlier, if the bank account is already printing this, we should not duplicate the code. Like again, we should not be doing the same things, right? So in a way, what we want to do is we want to say, okay, bank account is my parent. Okay. So parent, you go and print whatever you are responsible for. Right? So I call your print. After you are done, then I'll print whatever I'm responsible for, which is the interest. Okay. Okay, so we have yeah. Okay, so to override, we need exactly the same name and inputs. Okay. Okay, so this is the way to call a non-private superclass method. If the method is private, then of course you cannot call, right? Nobody else knows the method is in there. Okay, so this is very useful for overridden method, right? So why useful? Sometimes I override because I don't really want complete control over it. And sometimes you do, but most of the times you don't. Most of the time you want to override to inject your own customization inside. So you will call superclass method for the regular things to happen. Then I will inject my customization. Okay, so either before or after lah. So normally we override to introduce some form of customization. Then you go and somewhere along the line you might want to call your superclass method to run the regular things. Okay, so this is the superclass method. Okay. Now let's create an online e-account. Okay, our online e-account will charge a fee for withdrawals. Okay, so online, right? So you do all your online transactions, right? You transfer money. No need to. I don't give a bank book. I don't need to give you cash services, so to speak, right? But if you want to withdraw the cash service, then I give you a fee. Okay, so perhaps the first 2 withdrawal per month is free. Okay, so you can withdraw 2 per month. The next withdrawal, then you need to pay a fee. Okay, so now what methods do you need? I guess we need a method to reset counter lah. Like so, every month, you will reset the counter. So who should we inherit now? Right, our e-account. Should we inherit bank account or should we inherit savings account? Right. So let us take a look here first. Right. So let's say our e-account is a bank account. Right. So we just think about it. Maybe our e-account is not a savings account, right? Because there's no interest to be earned on. Okay. So our e-account is a bank account. So what private properties do we need? We need a fee, the amount to pay, and maybe we need a counter, right? How many withdrawals per month we need? All right. So in the so we start with 0, of course. The default value is 0. This is the constructor. Constructor take in account number and fee. Okay, so this one we did not take in any starting account value. Right, so never mind. We call the bank account only with this account number, and the starting balance would be 0. Right, the default constructor for this will give us 0 for the balance. Okay, and we set the fee to fee. Now here we override the withdraw function because we want to customize the withdraw function here. So how do we write it? If the counter is more than 1, Okay, we add the fee into the amount. Okay, then we ask the bank to withdraw the amount. Okay, but this withdrawal will deduct lah. Right. Of course, if you want to directly deduct, okay, so why we do this, right? So we ask withdraw to withdraw this amount, and then we add counter plus 1. Now, this is because withdraw will return you true or false, right? So withdraw is the one that checks whether you have enough money in your account. If there's enough money, it will deduct, right? So we add the fee into this. Imagine you want to withdraw exactly everything from the account, then you don't have enough money for the fee, right? So we put a fee in here. Okay, and only when the withdrawal is successful, then we plus 1. Okay, so I mean, you might argue that even if the withdrawal not successful, we should just charge the fee anyway, service charge. Well, you can implement that way lah if you really want to. Okay, so again, it's the behavior is up to you to decide. So here we only consider a withdrawal if you really can withdraw. That means we dispense for you the cash. Okay, if your amount is beyond the balance, then it's not considered a withdrawal. So it's not considered an attempt. Okay, so we don't increment the counter. Right. So only when we manage to withdraw, then we increment counter and then we return true. Otherwise, we say false. The withdrawal was not able to proceed. Okay. So, and then maybe we have another method called reset to reset our counter back to 0. Okay. So what do we have so far? So we have savings account, which is a bank account. We have E account, which is also a bank account. Okay. So let's see here. So let's create E account called 111. 150, $1.50 is the withdrawal fee. All right. So I deposit 1,000. Deposit works because bank account has deposit. Okay. I withdraw 200. I withdraw 200. I withdraw 200. Okay. So that means I withdraw 600. So I should leave 400. Should it be 400? Shouldn't be, right? It should be 400 minus 150, right? So this will withdraw 200, which leaves 800. This will withdraw 200, which leaves 600. This will withdraw 400 and 150. Okay, so it will leave me 398.50, right? Okay, 398.50. Okay, so this print will show I have 398.50. Now, if I want to withdraw this will fail because even though I have 398.50 in my account, I need to add in the 150 extra. Okay, so this will fail. So I will not be able to withdraw this. Okay, so you can easily type this in to your Visual Studio Code to play around and see how it works. Okay, actually I have the code but I don't know whether it's useful to show you the code but okay, I'm just telling you this is the output. Okay, right, so in a way, when you call this first withdraw, okay, your counter will plus 1. So counter is now 1. You call this next withdraw, okay, counter is not more than 1. Okay, so it will plus 1 become 2. When you call this withdraw, counter is now 2, right? So counter is now 2, you add the fee in. Okay, so here the fee will be added in. Of course, here you can do a EA.reset. Once you reset, the counter becomes 0. Then you can withdraw your 398.5 because there's no more fee. Okay. Okay. So now what we have here is subclass substitution. Okay. So the nice thing about using a subclass, remember at the start we said if you write some transfer function method or transfer function, you must explicitly go and handle bank account, savings account, e-account. Okay. If you don't have this inheritance. Okay. But with inheritance, what happens is that in any place where you need a super class object, say for example, bank account. Okay, a subclass is an acceptable solution. I can give you a savings account instead. Okay, I give you a savings account instead. Because whatever a savings account has, whatever a bank account has, savings account also have. Because inherit, right? So, but the converse is not true. Converse is the other way around. Not true. If I need a saving account, I cannot give it a bank account. Because the saving account might have certain properties or method that bank account does not have. Okay, so all functions that work with superclass object will work with subclass because the subclass has all the methods and properties that a superclass have. Basically, all the public ones, right? So all functions that work with the superclass object basically work with the public methods and properties, which the subclass also inherits. Okay, so they work with no modification. Okay, so this one only goes one way. Analogy is I have license to drive class 3 vehicles. Okay, so class 3 vehicle is a superclass. Okay, a Honda S2000 is a class 3 vehicle, right? This is a Honda S2000. Okay, thus I can drive a Honda S2000. Okay, the other way around may not work, right? If I have I don't know, if racing event requires a Honda S2000 race, right? I cannot put in any class 3 vehicle. That doesn't work, right? I cannot put in a Toyota Hi-Ace go and race. Cannot, right? So only the subclass, okay, can substitute for the superclass. Okay. So for example, our transfer function, right, used to take a bank account from and a bank account to, okay, and some amount, and we can withdraw from the bank account, withdraw amount from, and deposit to. Okay, so when I create a savings account SA and a bank account BA, now this transfer function accepts both SA and BA because SA savings account is a bank account. Okay, so this will work. Okay, so because the inheritance guarantee, right? SA, okay, in here, I will call withdraw, I will call deposit. So this is the SA. SA is the from. SA also have withdraw because it is a bank account. Okay, so it has withdraw. This BA of 2 will have deposit as well. Okay, so I can put savings account or E account into any of this. Okay, so for example, E account, right, is this. So let's see, savings account is this, right? So E account and savings account, both balance with 0. So BA equals to EA. Notice here, I can assign bank account. Bank account here is my bank account pointer. It can point to a E account. Okay, because here I'm expecting a bank account. An E account is a bank account. So it's directly substitutable. If I call bank account deposit 1,000, you deposit 1,000. If I withdraw 200, then this would leave me with $600, right? Then I will transfer, okay, from my bank account to the S account, $200. Okay, so this will transfer $200, okay, over. But the transfer, I think, if you go back, the transfer does a withdraw. Okay, my bank account, this BA is actually an EA. Okay, and this EA has its own withdrawal, right? Okay. Will the transfer now cause a fee to be levied, right? Because transfer does a withdrawal here. Okay, that is the next question. That is the question. Okay, that we'll look at in next week. Okay, whether this withdrawal process actually keeps account. Okay, so this transfer, okay, you can go back and try. Okay, if you and see what the result is. Okay, so we will not we'll talk about this more detail next week. Okay, where is it? Okay, so in a short summary, let's see. There are some pitfalls and rule of thumb, right? So inheritance feels very useful to have, right? But beware of overusing inheritance. Okay, later we'll see why, right? Overusing protected, because sometimes we may not want to allow our subclass to access the property. For example, earlier I said maybe our account number we should still keep private. Right? We don't want our subclass to just be changing the account number in that sense. Okay, so the more you keep private, okay, they cannot change. Of course, another way is make constant. Once you make constant, they cannot modify anymore. Or you can make it private. Make sure there is something inherent for future subclassing, then you make protected. Okay. Now, to determine if you should use inheritance, notice I always use the term is a, right? Inheritance is a. So is a sound like a correct thing to do, right? So if B is A, then it sounds right? Then we use subclass. Don't confuse with a has a relationship. Has a relationship is having something. That is called so if A has a B, sounds kind of right, then A should not inherit B. Instead, A should have a B attribute. What do I mean? So we see here, inheritance versus composition, right? So savings account is a bank account. Well, makes sense, right? Savings account should have everything that a bank account has. So we use inheritance. Savings account, inherit public account. Now, a person is not a bank account. A person has a bank account. Okay, so we write bank account, right? So inside our person, it has a property called bank account. So down here we have bank account. Okay, which means a pointer lah. Or here I use pointer lah. So this basically the contains inside, okay, the person's data. Right. Now the question is, if the person has a bank account, I can substitute savings account, right? Because savings account is a bank account, I can directly substitute in here. Okay, so this is the substitution, okay, that's allowed by subclass. And through this substitution, there's certain behavior in the methods, okay, that we'll look at next week. Basically, it's called the polymorphic. Okay, basically, it allows this thing, account, to function differently, okay, depending on what it is. Right? So a person can have a saving account, because we know that saving account can directly substitute a bank account, or e-account can also directly substitute a bank account, okay, by the substitution principle. Okay, subclass substitution. Now, the behavior of it, just now we did allude to it a little bit. Okay, we'll talk more about this behavior next week. Okay, when we talk about polymorphism, right? Actually, if you look at the time, we have 15 minutes plus. We can easily talk about polymorphic now, but the problem is too much information, I think, loaded in one evening already. Okay, that's why we have decided to space it out. Okay, I think for the past few years we tried this. It is generally quite okay lah. Okay, the feedback we get. Okay, so that's why we are ending early. Basically, because if we continue more with this topic, it could be a little too much for most people, right? Those with background in programming like Java, Python, maybe you have you can easily follow. Okay, but for today we stop here, where we go only into inheritance, right? So the substitution part, where you substitute saving account into bank account, is already talking a little bit on polymorphism, right? Basically, the behavior changes according to what actual account you put in. Okay, this we will look at next week when we talk about polymorphism. Okay, so for today, inheritance, basically we learn superclass and subclass. Basically, whatever the superclass have, the subclass will also have, right? And the subclass can override methods, basically to provide its own customization of things. For example, print, I can print extra attributes, or in the case of e-account, I override the withdraw. So I can do something, right? Like keep account of the number of times a withdrawal is happening, charge a fee for each withdrawal. Okay, so that is what we do in overriding. And of course, in overriding, you must have a way to call the parents, right? The parents method. Okay, to allow the parent to handle. Then we talk a little bit about subclass substitutability. Right? Whenever I need a parent class, I can substitute with a subclass. And because of this substitutability, sometimes the behavior may change. Okay, and this one we look at next week in polymorphism. Polymorphism. Okay, so this one, change of behavior, we will look at it there. Okay. So this is basically I think the textbook we talk about it, right? Smoke and walls and mirrors. Okay, so if you look at here, there's C plus interlude 1. I think inside this book, talk about classes. Interlude 2 talk about polymorphism and all that, right? So interlude 1 will probably be some exercises for your classes.